So let's understand what is convexity. Maybe first I'll give you I'll give you two ways of understanding what is convexity. The first thing is, so one example I'll start with. So y equal to f of x equal to h square is a convex function. Okay, this is one example of a convex function. Okay. So what is convex function? Let me try to intuitively explain you without going into very specifics. So you take any 2 points, so h1, h2. Okay, you take any 2 points h1 and h2, and you do this activity. First you take 2 points h1 and h2, and you take the average of these 2 points. Okay, so what is the average of these 2 points? Let's say h1 is -1 and h2 is, for example, let's say -1 and +1. Okay, now we'll do the following. First we'll take the average of these 2 points. So what is the average of these 2 points? 0, right? H bar is h1 plus h2 by 2, which is -1 plus 1 by 2, which is 0. Now first take the average and then apply the function. Okay, so now we first took the average, now apply the function. So what is the function of h bar? It is 0. Now this is about, we are taking first take average, then apply function. This is the first thing that we are doing. Now let's do the same thing, just interchange these two things. Okay, so we just interchange the activities. First we will apply the function, then we will take the average. Okay, first function, then average. So what will we get? F of h1 is 1, right, because it's -1 whole square. What is f of h2? And what is the average? F bar is f of h1 plus f of h2 by 2, which is 1. Correct? So which is greater? Which one is greater? The second one is greater, right? So if this is the property, then you call it a convex function. So you first take the average and then apply the function. The value that you get, if it is less than or equal to the value that you will get when you first apply the function and then take the average, then you call it a convex function. Okay, because 0 is less than or equal to 1, right? So more technically, to give the proper definition, we don't need to change much from this intuition. Like here it's very clear, right? Just take the, like you can also look at from this plot as well. So what is this value? Like the line, the average of f of h1 and f of h2 will lie on this line, right? Somewhere on this line. For example, if this was h1 and this was h2, the average will lie somewhere here. So if you draw a line, and if the line is above the curve, you take any 2 points, and if you draw a line, if the line is above the curve, we call it a convex function. If it is below the curve, then you call it a concave function. So here the line is below the curve, then you call it a concave function. So this is same as the inequality will reverse. Here if you first take the function and then average, you will get the opposite result. Okay, because it's a concave function. Is the definition clear?
Yes, sir.
Like at least the intuition is clear. I'll write the formal definition. So the formal definition just changes a little bit. Instead of taking average, you can also take weighted averages. That's all the definition says. So what is a weighted average of h1 and h2? So you apply some weight to h1 and h2 and then take the average, such that you give some ratios, like maybe 0.9 into h1 plus 0.1 into h2. So That is just the proper definition, is nothing but that. So what is the definition? If you first take the average and then apply the function, that should be less than or equal to first applying the function and then taking the average. So f of first taking the average, alpha h1, it's a weighted average, alpha h1 plus 1 minus alpha into h2. So I first took the average and then applied the function. This should be less than or equal to, first apply the function, you first compute f of h1 and compute f of h2, then take the average. This is called convexity. This should be true for all alpha belongs to 0, 1, because you are taking weighted average, the weight should sum to 1 and they should be between 0 and 1. It's like a fraction, you assign some fraction to this, some fraction to that, for all x, and for all h1 comma h2 belongs to R. This should be true. You take any 2 points and this should be true, any 2 points and any ratio that you want, then you call it a convex function. So concave function is just the opposite.